Okay, I think we'll start. So first of all, thank you all very much for joining us this afternoon here in London, and also to everybody who's watching the streaming version on Facebook and YouTube. We're very grateful for you taking the time to come and listen to us talk this afternoon. My name is Matt Wicks. I'm the co-CEO for Technology and Innovation of the Virtual Forge. The Virtual Forge is part of the Dream Tech Group. The format for this afternoon, you will have seen on the invitations, is that we're going to do a very short introductory piece about who we are and what we do. We're then going to do a little piece about what AWS is, and then we're going to dive into the deeper subjects, looking at the analytics platforms, looking at the AI platforms, looking at the options that exist within Amazon Web Services to provide you with these solutions. At the end of the session, at about 4:30, we have a question and answer session. And then, perhaps most importantly, after that, we'd like to invite you all to the bar, where we'll be mingling and happy to answer any questions that you have in the meantime. If you'd like to, on the way out or in the break time, feel free to take one of my business cards here or talk to some of my colleagues who are here, and I'm more than happy to answer your questions. So, let me start by telling you a little bit about the Virtual Forge and about the Dream Tech Group. So the Virtual Forge, as I say, is part of the Dream Tech Group. We're a software development company who specialize in the full process, from the very beginning part of requirements gathering, through the UX side of things, through design, through the software development process, working with you to create the solutions that you want. We're very cloud-centric in the way that we work, and that means, as you'll see hopefully in some of the things that we talk about here, it's not simply a question of taking a piece of software and putting it in the cloud. It's actually designing from the base up for that, and that means multiple different levels. We have a very strong testing department. We have a strong security department. In fact, we actually always joke, our security department, the person who heads our security department recently came from working for the National Lottery in Portugal, and so if it's good enough for them, it works for us. But he still hasn't told me how to kind of win the lottery, which is, maybe his next raise will get us there. We have a global presence, either directly or through working with the Dream Tech Group in all of these various different places. From a software perspective, we are primarily based in London, in Bath and Lisbon, but obviously within the Dream Tech Group itself, which comprises both the Virtual Forge and Dream Tech, which is a video production company, we have presence in all of these various different countries. These are a few of our sample customers. Obviously, there are many more than this, and we're happy to talk through and give you specific case studies if anybody's interested in relation to that. So, five slides only about us, and then we'll get into the meat of things. We like to style ourselves as a creative technology company. That's a company in which we look at the problem from a technological perspective. We look at what you're trying to do from a business process perspective, but we try to come up with solutions that actually are innovative and creative. And more often than not, that involves using some of the new tools, some of the new services that you're going to see here today through AWS and other partners that we work with. So we are also very, very focused on UI and UX and measurable UX, making sure that we understand when we go into a situation, when we go into a process where we're building something, that the user is at the front of that experience and that those are measurable experiences. Now that may seem to be kind of removed from what we're going to talk about today in terms of AWS, but actually I'd say it's one of the core things, because what AWS allows you to do in a very cheap and cost-effective way is to scale up and to produce analysis at scale of all sorts of things. We're going to use Twitter as the example, but any sort of analytical information that can come in from the work that we're doing on various different scale websites and solutions allows us to take the creative vision behind what we're building, to understand how people are really working with it, and to make dynamic changes as we're going along as well. we're very dedicated to providing world-class customer service, and that goes right the way through everything that we do. It goes right the way from the requirements gathering process, which we see as a highly collaborative process, through again to the UX process, which we see as a highly collaborative process as well, understanding what it is that your customers need, what it is that you need, and how we can best facilitate that. But that also actually feeds into the work on the cloud and the work with AWS. Because again, when you come to look at what you're going to do, whether you're building services in the cloud, whether you're building software that's going to be migrated to the cloud, actually understanding and really getting to grips with the global nature of the product that you're building, with the actual changing nature of the way in which people work during a day. So for example, just to give you one very good example, we've had an engagement with a large corporate in which we've been required to deploy to 87,000 users. And in part of that process, those users not only in different time zones, they're also constantly putting different demands on the infrastructure at any given point and in different areas of this piece of software as well. So it's very important to map things from the ground up. Okay. We begin our process of working with people with user-focused workshops for requirement gathering. That, as I say, is very focused on the UX and making sure that the end experience that we're delivering is the one that works for you. But it's also focused on understanding what are the processes underlying that you're trying to drive forward, so that we can begin to really make an understanding of the best way to architect your solution as well. Come in, don't be shy. Someone is going to have to go at the front. I'm sorry. Okay. End-to-end software process, the key, the heart of what we do. Again, it's very important for us to foster the development of all our teams, our PM team, our security team, our test team, our software development team, and so on. It's very important to foster the ability for them to learn new skills. And that's particularly important in the context of what we're looking at here. Because very often, although the solution is a technological one and may come from an architectural side of view, actually what you want to do to deliver people is to have the UX guys be able to talk about how an analytical solution can work for a client. What you want to do is to be able to have the security guys be able to talk to the client about how building a piece of software in a certain way is going to give them better return and is going to be able to give them a better and more secure solution. You want to be able to have people who understand the whole process from end to end. You know, I think often it's a mistake to think of the cloud, AWS, as the destination. AWS is there throughout the whole journey, and that's kind of how we filter things through in our processes. It's really important in terms of how we do. So probably the most important line there is cloud applications are in our DNA. We build for the cloud, and we move to the cloud as much as possible. Okay. We have, as I say, a very strong testing department. So it's an independent testing department. We have systematic, strategic, and objective results analysis. We make sure that everything we do is thoroughly tested, of course, from a unit testing, from a functional testing, from a regression testing perspective, but also from a UX testing perspective. And we're very keen on making sure that we can quantify the user experience that we offer. We also, in the same way, provide analytical insights into the security testing that we do. And again, just to say about the security testing, our philosophy there is very much about a security test is not the thing that you do at the end. Security consultancy, the building of the system from the beginning right through to the end is really important. And we like to weave security through everything from the start. Our developers work very, very closely. The architects work very, very closely with the security guys to build out security, which means more often than not, what we're actually doing when we're architecting the system is driven with a security first perspective in there as well. Okay. And that's my security slide. So there you go. And we also have a full support desk, which is run by my colleague Mike there. The support desk provides, at the moment we're providing global coverage, and we have the ability to be able to scale up in different regions as well to provide support. And this is support at various different levels. It may be application level support, it may be infrastructure level support, so hosting support, or it may be just support in the usage of various applications that have been built or designed by us. It's also important to say that, as I mentioned at the beginning, We are very closely integrated with DreamTech, who are doing the live stream here. And that's important because as a video production company, we work very closely with them in things like global distribution of video content, being able to create applications around video, whether those applications are based around 360 video, virtual reality integrated video, but also where you have, for example, just to give you another example, a large bank which has to distribute video content throughout all of its global infrastructure at certain key points in the day. Market information will come into that bank, and it's very important at that point that the network is not being clogged up with video content, because obviously that will slow down the market information coming to the traders only by milliseconds, but has a significant impact. So the two companies working together, using both the infrastructure, the security, and the software development, and the streaming expertise of DreamTech, are able to provide solutions in that environment as well. So we cover both the soft and hard media side of things as well. So that's us. I'm sure that's the reason you all came here, just to hear about us, none of the AWS stuff. But should you wish to discuss any of this further, as I say, my partners and I are here, more than happy to discuss, or to take one of the cards and we can pick this up as we go through. Or alternatively, let us buy you a drink in the bar afterwards. Okay. So, AWS. Just to say before we go into this, we have a very mixed group of people who have signed up for this event, which is fantastic, both online and in person. So the way that I'm pitching this event is I don't just want to show you a bunch of slides, although this is a slide. What I want to do is to show you a few things under the hood, to actually show you things working so that you can see how they work, and to share those with you. But at the same time, I'm aware that not all of the audience are from a technical background. Some of the audience are more from a marketing background, from a commercial background. So we're going to be kind of dipping into some things, coming out, dipping into other things. And where you've got specific questions, please do ask those questions. But I'd ask you to keep those questions for the end of the session at 4:30, just because there's a lot of material to go through. Am I outshot?
Yeah, you keep them walking.
Okay.
People are going, tell them this.
That's it. And completely put me off my show. So at 4:30, we're more than happy to do a Q&A, or again, as I say, ask us the questions in the bar afterwards. This is designed to be a taster of some of the elements of AWS that are not that are either newer, or some of the elements of AWS that are not always spoken about. Where you see technical screens, if you're not technical, just follow the story through. We don't stay in a technical element for very long. If you are technical, I understand there'll be frustrations because we don't go deeply into it. Again, you know, I'm technical. I'm happy to answer those questions after the event as well. But first of all, just to talk about the bits of AWS that are well known. AWS is typically certainly according to the Gartner Magic Quadrant, the leading cloud provider. And what that means, I think, is really important. Conceptually, the cloud is a bunch of computers, a bunch of servers that are sitting in different data centers around the world and are joined together. But that is nothing to do with what makes AWS so powerful, and also the other cloud providers so powerful. What makes them so powerful is the complete change in mentality in the way in which you're able to consume and build and use services. The thing that makes this so great in the way that it works, and also so cost effective, is the fact that you can build your systems in a very different way. You can, of course, take an existing infrastructure and take it like for like, lift and shift, put it in the cloud, and you're pretty much guaranteed that you'll save some money. Brilliant. But there's so much more to it than that, and there's so much more you can do to that. And a lot of what I'm going to be talking about today is about those other things. And it's important to say that AWS started in 2006, so it's 10, 11 years old or so on. They're adding around about 300 new services every year. And every week you'll see that there are new additions being added to each different piece. So constantly things are being upgraded and moved and improved all the time. And that's in response to the way in which people are using systems, as well as in response to their roadmap. It occupies 42 availability zones within 16 geographic regions. For some of you that will mean a lot, for some of you it won't. What it means is there are an awful lot of data centers that AWS are running around the world. And that's really important because it means that when you're trying to deliver video content, you can reduce latency quite considerably. When you're trying to ensure global distribution of a system, you can do that relatively easily. And when you're trying to ensure a resilient system, so that if you have, for example, a good example that we have, for example, is we have a system in which we are constantly collecting geographical waypoints from in-vehicle software. Now this means we're getting millions and millions of waypoints of data every minute. And clearly we want to make sure that in a disastrous case, let's say for example the whole data center went down, we don't want to lose that information. It's very easy to architect a distributed situation so that you can make sure that your data is protected by having a bit here in Brazil, a bit here in Singapore, a bit here in America. I mean, that's a very simplistic view of it, but that's the sort of thing you can do very, very easily. And there are 3 more regions which have been announced. One of the questions you can't ask me at the end, I'm afraid, is which ones, because I did look it up, but it's completely gone out of my mind. So, but it's on Amazon's webpage anyway. Netflix is largely based on Amazon Web Services. This is just one example. There are many more. And at peak time, it accounts for 37% of all internet traffic at the US at peak times. That is a phenomenal amount of internet data that is being routed through AWS at any one point. And how can they do that? Well, they do that because of their core concepts. And this is the really, really important thing. Essentially, the typical model of building any system, of doing any work, let's say you're doing some data analytics, you need to have a massive server, and that server is going to be running for 8 hours a day. Fantastic. But you're paying for it for 24 hours a day. And the core, original point of Amazon was that actually you could make a totally different setup. You could have a system that you turn off for those other hours of the day, other 16 hours or whatever, 10 whatever hours of the day. You know, so you can turn it on and you can turn it off. If you have, as we very often do, especially on the Dream Tech side, you have an event where you like today, you need to have a bunch of machines that are running and you only need to have them running for 2 or 3 hours. You can turn them on and turn them off at will, and you only pay for what you use, which is amazing. You also have the concept as well of being able to grow dynamically. So without any human intervening and coming in and saying, oh no, our website's getting thousands more hits than we expected, quick, let's shuffle in a couple more servers. You can actually write scripts, you can set up commands, which will automatically increase and decrease the amount of systems, the amount of infrastructure you're running in response to whatever is happening on your system at any one time. That's brilliant for 2 reasons. The first reason is it means you can accommodate surges. So great example is very famous ticket website, again, hosted in AWS. Whenever they put live, for example, I don't know, recently they just put live Queen are doing a revival tour, well, part of Queen are doing a revival tour. And so they put out the tickets there. You're going to get an upsurge at 10 a.m. in the morning when they put them out. You need to be able to grow to accommodate that. But by 2 p.m. in the afternoon, it's all going to have dropped down at that point as well. So you're able to build an infrastructure which is elastic, which grows and shrinks according to the usage of your system. That's great. That was where they started in 2006. It's got way more exciting than that now. A lot of the stuff I'm going to show you now, in the stuff that we're going to look at today, there is no infrastructure. You don't build an infrastructure anymore. You build a bunch of connected services, and those services actually handle all of that stuff for you, which we'll see as we go through. Redundancy, again, really, really important concept when you're building anything, and you'll see even in simple things that we want to build, you want to make sure that whatever you're doing, again, let's say you're doing some sort of big data platform, you don't want to run the risk of there being, you don't want to run the risk of the system falling over or anything like that. You want to be able to make sure that it has redundancy built into it. Again, this is very easy to do in AWS. It's built to do that. The very first piece I'm going to show you as a demo actually allows you to see how you can completely build something from a single page. Global reach, I mentioned we have the 42 availability zones, 16 geographic regions. This means that there is always an AWS region or a data center near you, and that these services are available. Now this is really important in a couple of ways, one of which is, as I say, it allows you to reduce latency, but also the pricing for these regions is different as well. So by being sensible in the way that you plan and by looking around and taking time to understand what you need and where it is, you can actually reduce your overheads quite considerably by putting them in different regions, if that's a possibility to do. It also means when governments bring out new legislation, such as recently, for example, you need to put EU data inside the EU or Russian data inside Russia, for example, those are much easier to accommodate, because the fact of the matter is you can actually create clones of your system in different environments. Of course, I'm making it sound very simplistic. Anybody who's technical here will know it's not quite as easy as that, but the principle is really important. And it does mean as well that if, for example, you are having a marketing-led campaign and that marketing-led campaign needs to suddenly hit 1 million users, and you know you're going to do that for a 1 month period, you're not paying massive overheads for that particular period of time. You can start small and you can scale up as you get those 1 million hits. So if you don't get them, then you're not paying for them. Pay for what you eat, again, is a core principle. You don't pay for the system, you pay for the service that you use at any particular time. One of the core things I'm going to be talking about is something which is called Lambda, which we'll see, which basically is a way of actually reducing your costs down to milliseconds worth of equipment, and is very important in both the AI and in the analytical part that we're going to see. Okay, just very quickly, because you'll see these mentioned as we go through. I'm not going to go into great detail about these because these are very well-known services of AWS, but for the benefit of people who don't know, core services in AWS which are underpinning everything else that we're going to talk about. EC2. EC2 is basically the ability to create machines. So if I want to set up a database and a web server, there are lots of different ways I can do that. One of the ways I can do that is just going into Amazon, going into their EC2 console, which is basically says, yes, I want a Windows machine, I want it to be in Ireland, I want it to be this sized machine, this big machine, and I want it to be able to handle 5,000 users or whatever. And that will then create that machine for me. Okay? That's the oldest and simplest, and still in many ways the core of that process. RDS. RDS is a managed database service. So typically you would, in the older way of doing things, you would have a database or a database cluster on site. You would have a database administrator to manage it. You'd have your system guys to manage, to patch, and all of those sorts of things. This is a service that you can use. It supports most major database types, but effectively it means that you can use the database without having to manage any of the system behind it, without having to worry about the security patches and any of those things. That's all handled for you. CloudFront. CloudFront is a content distribution network. So it basically is a way of, for example, when we're broadcasting today or whenever you're distributing websites, in order to make sure that every time somebody who's logging on from Australia doesn't have to then get the image which is stored in let's say, for example, in London, typically they'd get it from the server in London, and the next time they'd come, they'd get it from the server in London. The way that CloudFront works is it allows you to, it caches everything locally. So it stores everything locally, so the next person in Australia who's coming to look at your web page doesn't have to get that image from the main server, it can get it from a local server, so it allows your content to be distributed much more easily. And also, the video content, for example, is distributed largely around the world. So it gives you the ability to have a very easy way of broadcasting your content. Finally, S3, we're going to see this one particularly several times today. S3 is a bucket. It's basically, it's what they call a bucket. It's a storage folder that you put content in. So you can upload whatever type of files you want to upload. You can upload CSV files, Excel files, you can upload PDFs, you can upload images, videos, whatever you want, anything you would put into a folder. Those of you who use Dropbox, for example, are actually using a wrapper around S3 to share files with different people. It is essentially a storage medium, which is used as the basis for everything. But as we'll see, it's used in quite a lot of different ways. So, in order to give some sort of narrative to what we're talking about today, and to look in particular at the analytics solutions, at the Kinesis solution, at the artificial intelligence solutions and so on. There are a number of different ways that we could do this. I could just go through some slides with you, but I don't want to do that. What I want to do is show you a few working demos of of an application being built or being used. Now, the process and the story behind what we're using here is one that you'll see lots of examples for on the internet. There are lots of tutorials you can download to follow through a lot of these things as well as you'll be able to follow tutorials on our blog after this event. The idea is we're going to take in some Twitter data, lots and lots of Twitter data, because it's high velocity, high information data, and we're going to take that data, and when we take that data in, we're going to do a number of things to it, one of which is we're going to process it for sentiment. So we're going to ask a process to run which says, is this a positive reaction, is this a negative reaction, and so on. We're going to focus in particular, as we go through, on 3 specific brands, which are Nike, Pepsi, and United Airlines, because for obvious reasons we're going to get some information out from those. And we're also going to then, as we go further into this, look at how we can take it further and do image analysis on images that are taken on Twitter for those brands and produce a sentiment analysis for those as well. As I say, this could get very, very technical. I'm trying to kind of steer the middle ground. So here we go. The first thing to say, the first thing I'm going to do is, and also just to say that I'm going to be doing this in the form of a number of, videos along with the slides, largely because there was so much material to go through. I didn't fancy trying to do 2.5 hours of live demos with questionable internet. So the first thing I want to talk about before we get into the meat is something called cloud formation, because this is very important to understand, and this probably is one purely for the more technical people, but it's important to understand from the perspective of a business owner and how this adds additional security to what you're doing. So let me okay, so the first thing I want to talk about is cloud formation. And this is a really short demonstration, but you can see. So cloud formation gives developers and system administrators an easy way to create and manage a collection of related AWS resources, provisioning and updating them in a predictable and orderly fashion. This basically means that I can create a process, which I'll demonstrate, which will create for me all of the software, all of the hardware that I need to have created. So I'm going to do this big data analysis of Twitter. In order to do that, I need a bunch of services to be created. I'm going to, and I want to be able to do this, but it's quite complicated. I don't want to keep having to go into the console and create something. I also then, once I'm happy with it, I want to be able to farm it out to other members of the team to be able to repeat this process very quickly with other clients, so that if another corporate comes to us and says, actually, you know what, we want to do this process as well, I can actually run the system up for them reliably and repeatably within 10 minutes or so. And the final thing to say is, in the worst of all possible worlds, if my system goes down completely, I can just repeat this process and it will rebuild my system for me totally. The reason I'm including this at this point is so that you understand just how automated this part of the process is, or how automated AWS can be, and how easy it is to create something that you can repeat again and again and again for different environments. So we're doing a Twitter analysis now. Maybe I want to do another one in 6 months. I don't want to keep everything going for 6 months. I don't want to mothball it for 6 months. I just want to pull out my script and run this script again in 6 months and see the process happening. There is no cost for this. On the right-hand side of my slides, as we go through, you'll see the cost information. There is a cost for the resources you create, but the actual process of running this, there is no cost associated with. So, just to show you how easy this is, I'm going to go into cloud formation. Cloud formation will allow me to create what they call a stack, which is effectively a whole bunch of different machines. And these different machines can be used for different purposes. It can be any of the services that we're going to see today on AWS, but this is basically just a way of me being able to create this content. When you go through it, there are a bunch of steps that you have to take. But the great thing is you can also change options each time you go through it. So you don't always have to create exactly the same items every time. So it might be that we're running a smaller system for one client, and then Pepsi come to us and say, you know what, actually, we want you to run this system. And I think, well, hang on, The two machines that I had last year are not going to be sufficient for this, so I've got the ability to be able to parameterize it. You'll see here now I'm entering an IP address, so for my security aspect of this, I'm making this entire stack only accessible from this one key point here. And one thing to say about AWS while this is running is it allows you very, very granular control of security. You can lock out machines, you can lock out services, you can lock out users, you can integrate with Active Directory, you can do a whole bunch of stuff here. Okay. So remember, what we're doing here is putting in place the building blocks, the struts that we need to begin to do our data analysis. So it's now running through, all I've done is uploaded a script, it's running through and it's going to begin to create this, this process. This part of the process actually takes about 25 minutes, but I've sped it up because it would be a pretty boring presentation to watch. And then we get to the end. You can see here it's created an EC2 instance. I'm just going to go and verify that it has in fact created that instance. And these are all the Amazon services. And you can see here the one at the bottom, which is initializing, is the one that's being created. So this is actually a server sitting in the cloud with some code that I've written that's running on it, and it's gone away and created that. Don't actually need to do that for this Twitter thing. As I say, we can do it completely without servers, but just to demonstrate that part of the process. The great thing is as well, is if you create something like this, you can also then go back in and change it after the event. So let's say, for example, I've created something which is going to be doing image analysis. It's going to be going through and doing some deep analysis of an image. I come in a bit later and I decide that instead of just saving that information out in a database, I want to be able to take those images and put them into somewhere else, as we'll see a bit later on. That part of the process can actually be changed simply by uploading an updated script, which is exactly what I'm going to do at this point here. Again, updating a script, it changes only the pieces of hardware that need to be chased, gives me a few options, and I can choose to make them optional or not. As I choose, I can choose the names of whatever I want to do. So it's repeatable again and again and again, and it's very quick to rebuild a system, as I say, as needed. But it gives you all of the different infrastructure elements that you need to have. And of course, it allows you, this is the important part, to preview the changes. And as you'll see in here, in order to do this, there's a whole bunch of things that I've needed to create in order to make this process run. And this is just verifying that I do in fact want to create a database, and I do in fact want to change the permissions that I've created. It will then run through and create that again. Okay. So this is all happening in the background. This is allowing me to do this. So if we wanted to today, I could have started the session by running this script, and you could have seen in real time all of these items being created. So CloudFormation is a core part of working with Amazon Web Services. And it's a really important part of tightening your security and a really important part of being able to make your process reliable. Okay, so let's start looking at how we're actually going to gather all of this information that we need to gather. There are lots of different ways in Amazon of being able to gather information to feed into an analytics tool, or to feed into a machine learning tool, or to feed into an artificial intelligence program. But one of the most important is Kinesis Firehose. So if you think about it, what we've got, if you want to create and gather a large amount of data, let's say, for example, a Twitter bubble, Twitter field. You want to capture all of this information. The chances are you're going to have thousands and thousands, if not millions of tweets coming along every minute. You're going to want to get the images if you're going to do the image analysis. Maybe you want to bring in Instagram, Facebook as well. There's an awful lot of data that you need to be bringing in at any one point. So what you need is a reliable way of capturing all of that information from wherever it is that's being brought in, all of those different streams, and those different streams need to be reliably delivered to the end point that you're going to be working with. Now that end point could be a database, or it could be an S3 bucket. So one of those buckets in our process here, what we're doing is we're taking all of these tweets that are out there, and what we want to do is save them into a bucket. Okay, so they're just text that's being sent, and we're going to save them into a bucket so that we can then do some analysis on them, and get some idea of the sentiment behind them. And this is an incredibly powerful tool. So to do that, we're going to make use of Kinesis Firehose. Kinesis Firehose does just that. You plug in your streams of data that you're wanting to send, and it will reliably deliver them to the endpoint that you've set up. There are two different versions of this. We're focusing on Firehose because what Firehose does quite nicely is it makes the decisions about what hardware you need and the amount of data you need at any given point to bring this through. So Kinesis is a platform for streaming data to AWS, as I said. It makes it very easy to load and analyze stream data, but also provides the ability for you to build custom streaming data applications with specialized needs. So one of the examples here is exactly this. I've got this data coming in. A couple of things I'm going to want to do. I'm going to want to analyze it in transit so that in nearly real time I can see what's happening. I also want to be able to save this data out so that I can do my sentiment analysis. Prices are on the right-hand side. The volume of data you transmit through the service is so for the first 500 terabytes per month, it's £29 per terabyte. Sorry, $29.029 per terabyte. You can read it easier than me saying it. Okay, so it's relatively cheap, but again, it's that concept of you pay for what you use. So I'm going to set this up. So I've already got a stream that was created by that script that I ran a little while ago, although we'll see creating a stream in there in a moment. I'm going to create a Kinesis Firehose stream, and then I'm going to perform some analytics on it in situ. So this is my search stream that was created earlier on, and it's literally just linking some data to an S3 bucket on the right-hand side. So it's taking the tweets and saving them and just making it reliable. You'll see here, I can see the amount of data that's been going through in the last hour or the last 24 hours. So there was a huge amount of incoming records there, about 3,000, which then dipped down to for a while and then shot up again. In this case, it's because I was watching particular hashtags, and in this case, it was United Airlines, and obviously when America was online, it was slightly more active than when it wasn't. You can run a test if you want with demo data to push through, but my data is all coming from, as I say, from the tweets, which I can monitor on a regular basis. Okay, so now I've got that data coming through. It's going from A to B. It's going from Twitter to my S3 bucket. But in that transit page within Firehose, I can actually do some real-time analysis on that data as it comes through by creating what's called an application. So I'm just doing that here, using the wizard, creating an application. All I've done so far is I've given it a name. I connect it to a source or a stream. So that's the stream I've got. It will then read the schema, it will read the structure of the information that I'm putting in. For some reason, it failed the first time, but never mind. It's the second time, and now I can see all the data that's in the tweet. The ID of the tweet, the text of the tweet, the time it was created. That's what it looks like in its raw form. So to get some real information out of it, what I want to do is I'm going to whittle down this information, though, at the moment to make it easier for us to understand what's happening. Because if you look at this as is, there is an enormous amount of information which comes out of every tweet. So the name, the screen name, the location that somebody is at, whether it's a protected tweet, the number of retweets it has, all of that information is really useful when you're providing it, when we come to do the analytics on it. But it's going to get quite confusing if we just sit and look at all of that. So I've narrowed it down a little bit here. And I've narrowed it down here to just those fields. So I'm just going to be analyzing the created@, text, language, the hashtags, and the timestamp. And a really simple example to show you how you can do this in real time is once this is saved and updated, I've got that information in there. See, it's coming from various different countries. I'm not doing any filter on country. I can see the hashtags that are being picked up in there. So if, for example, I wanted to see Pepsi, I could just do some analysis and filter purely on Pepsi. But let's do some real-time analytics. There are templates in there which allow you to do real-time analytics on the data. Let's not worry about the destination stream. So if we go to the, yep, there we go. Allow you to do things such as detect anomalies in data, allow you to do things such as aggregate data in real time. And remember, this is just the very top level part of the process of what we're going to be doing. So here I'm going to run just a standard SQL query, a standard query, which is going to allow me to see, to make sure that it's working and make sure that I'm only pulling in tweets that have actual text in them. Which it does. And remember here it says the new results are added every 2 to 10 seconds. The results below are sampled. That's an important thing. If you're dealing with millions of results at a time, you don't want to see them all in this window, but they will all be saved for you in the destination, which is important when we come to look at the analytics tool, because that is where you can use your information to do your analysis from. Okay. So this is just showing a simple example. If I want to see something which has a bit more structure to it, oh, there we go. I'm now going to do here a search for hashtags which contain the word job. So I want to see here, for example, how many jobs are being advertised on Twitter at any given point. This is a rough, quick and dirty, how many jobs are being advertised, or how many things with the hashtag job are being advertised at any moment in my subset of data. And so this is being pulled through here. Okay. Now, in order to, and so you can do all of this, and you can save both this and all of the information out that you're doing. Then you can see here all of these. Our latest hashtag job offering this hashtag job, hashtag so it's pulling out that information. And again, this is being done in real time, so we are able to take it, analyze it, and it is being saved into a destination bucket. So what we've got so far is a whole bunch of data being collected, coming through Kinesis. Through Kinesis, we are able to see at any given point, by doing this sort of snapshot analysis, a feeling for what's happened. But we can also save out those real-time analyzed results. So we haven't got any database running here or anything like that. It's just running through. And we can then, if we want to, analyze those results from our destination. We can store this information, all of these different rows, in one of Amazon's databases or Redshift, its data warehouse, and we could then perform analytics on that information. But in and of itself, that's just the first step. What I actually want to do is I want to be able to process this a little bit further. I want to be able to, as I said, to perform a sentiment analysis on it. So every single time one of these tweets is collected, it's gone through its processing, but what I want to be able to do is run a little program that will say, we'll read the text, we'll read the emoticons that are in there, and we'll make a judgment on whether it's a positive, a negative, or neutral sentiment. Now there are loads and loads of sentiment libraries out there. The one that I've used here is one called Sentimental from Node.js, but there are loads and loads of different libraries you can get to do this process. The important part from an Amazon perspective is that we're taking the tweets that we've collected, and every single tweet we're performing this analysis on. Okay? Still no servers. Okay? And that's important, because what I could do is, in order to perform that, I could get 15, 20 servers set up. I could pull in all this information. I could write a program that runs all that time. Then every single time I want to update that, I could put the code on each of those servers. I could monitor those servers in case of falling over or what have you. Or I can make my life easy. So key to understanding both this and when we later come on to do voice recognition is something called Lambda. And I just want to talk about that for one moment, because it's really important in terms of understanding what Amazon can do for you, how Amazon's moved forward since its original model, and also how you can get the best return on your investment and save the most money. So Lambda is a compute service that lets you run code without provisioning or managing servers. So if you want it to do something, in our case we want it to read a tweet and we want to make a judgment on whether that tweet is positive or negative, I don't have to set this up on a server. I can put it into Lambda. And that basically means that whenever I tell it to run this, and I'll explain how that happens in a moment, whenever I tell it to run this, it will run this little bit of code, it will create the servers that are needed, it will do all the provisioning of those servers, it will make sure those servers are secure, and it will run all of that stuff without me having to think about infrastructure at all. You have to pay for the compute time that you use. So you have to pay, for example, if I have my system running for 100 milliseconds, I have to pay for 100 milliseconds. If I have it pay for 200 milliseconds, I pay for 200 milliseconds. That's all. In terms of the cost of making a particular request, the first 1 million requests a month are free, and then it's 20 cents per million requests thereafter. So it's not going to break the bank in that perspective. Obviously, though, if you have millions of tweets coming in, you know, it's going to run this process a lot of times. So there's an awful lot of scalability that needs to happen here. And again, what we're doing here is we're collecting data and we're pre-formatting data so that we can run other tools on it. And in order to do that, we need to run through this process. So I've already created a little function here. And in order to get it to work, the key things are I can just upload some code. Again, for those of you who are more technical, this will run in Node.js, in Python, or in .NET Core. And it's simply, in this case, it's a one-page JavaScript function. And the important thing here, just to step back to this, is, which I've just missed again. Is that it's connected to my bucket. So my bucket is called Nike Tweet Bucket, which is where all my Nike tweets are saved. Go figure. But basically what this is saying is every time a new tweet is added to this bucket, then what we want you to do is to run this code. So every time a new tweet is added to this bucket, we want you to go away, we want you to run the sentiment analysis, and we want you to produce we want you to add some data as to what the sentiment of that tweet was. And it will run all of this, and what you'll be able to see in a second is when I go to the monitoring, again, I can see how many times this has been called, 4,000 in the last time, with a maximum time of 4,395 milliseconds. And when I look at this, you can see, just to show you this bit, the billing duration, which is right at the bottom there. The build duration is 1,200 milliseconds of time. So again, you really are only paying for what you want. You haven't set up any machines or anything like that, but you're only being billed for that time. So it means that you can scale up your data really, really quickly, and you can make use of that really, really simply. Okay. And then just to show you what's being outputted from that, it's run through, and inside my bucket, it's created a lot of tweets so far. And it's created a chunk of data. Again, it's still in its raw form. We haven't visualized anything yet. But what's important is you should be able to see in 1 second, here we go, that for each of those tweets that's been added, we've whittled it down, as we saw, to its core elements. But we've also got here the fact that it is sentiment positive, sentiment negative, and so on. It's done the analysis, and it's got that information. We now know what the sentiment of that tweet is, as far as the library I'm using is able to do that. So now we get to the part where I'm able to analyze the real underlying data. I've got millions of tweets, and I want to be able to go in, and I want to be able to analyze this both from a kind of statistical perspective and also taking it into an analytics tool. So what I'm going to do in order to take it into an analytics tool is I could put it in a database. But I'm trying to do this without building databases. I'm trying to keep the cost down. I'm trying to do massive scale, and I want it to be brought in. And right now, I'm kind of doing ad hoc work. So instead of using one of Amazon's typical traditional databases, I'm actually going to use something called Athena. So Athena is a very interesting service. It's an interactive query service that allows you to do live querying on S3 data. So think about what I've actually got. The output of all of that is a whole bunch of text files. And in those text files is some information that says this is positive, this is negative, this is negative. What I can do with Athena is actually query those text files. It's typically used in analyzing logs for large events and so on, and on servers. So it's $5 per terabyte of data scanned. So that's incremental as well. So it doesn't mean each time you do a scan, it charges you $5. It means that when you've eventually scanned 5 terabytes worth of data, it will do that. And this is quite exciting because it allows you to immediately start to pull out really meaningful information from flat file data without actually needing to put it into a database. So I'm not building a system. What it calls a database is just a reference to my bucket. Now, in order to keep this moving, I'm going to just skip forward a little bit here. So basically, at this point, I'm creating a table in the database, and I'm just specifying each one of those fields available. So what I get at the end of it, once I've run all of this, is the information that I want. So all of that information is now available to me inside of Athena. Hasn't built this into a database or anything else. It's actually querying the data. That's really important because if you think about what we've got running, we've got Kinesis, which is sending live data out. And so all the time, Lambda's running, everything else is running, but the key thing is all the time, more and more and more and more data is being pumped into my S3 bucket all the time. So I'm able to query this, and I'm able to see that at the moment I have 148,418 records, and then the next time that this runs, which will be in 5 minutes' time, you should see that that number increases. And I'm going to use Athena as the basis for working with my visualization tool. So I haven't had to go through and create and set up a whole bunch of new servers or anything. I'm able very quickly, on an ad hoc basis, to create this information and to start to query it. Of course, you could go and set up the servers and you could set up the databases and all of those things. But this is just an alternative way. Everything that we do from here is the same thing. So I've got more data coming in now, more data coming in now. It's running through Kinesis, Lambda, it's doing all those processes. And now, soon, nothing like watching tweets come in. Yeah, I may have recorded this bit a bit too long, sorry. I got carried away, the geeky side of me. Okay, now, if I run the same query and move my mouse, oh sorry, we can jump across to Lambda and we can see that at 9:45 it ran its process, it did its tweet analysis, all of that happened under the hood, and the last time it ran for 300 milliseconds, so my bill now has another 300 milliseconds, wow. And then I can run my query, and now I have 153,816 pieces of information in there as well. And as you would expect, if you want to drill down into this, you can just run SQL queries here. Now this is not going to give you any nice visuals, that's the next bit. But at this point, you can actually run standard Hive queries on here. So let's see how many Pepsi tweets there are, which are I'm just looking here to see which tweets are from Pepsi and which tweets and how many tweets are positive. That runs, oops. Spelled hash. That runs and it will give me a list, sorry I wasn't doing a count there. It will give me a list of all of the positive tweet, or 10 of the positive tweets from Pepsi. So I can start to look at those and see patterns in there. Likewise, I can do the same with negative and I can start to see what people are complaining about or retweeting, and it tends to be the same tweet in this particular example all the time to get that. Okay, so on one level I can do some fairly simple, fairly nice analytics on this at this point. And again, just to stress this is in Athena. I haven't had to set up a whole complicated database. The data that's coming through is being pulled through in real time, or almost real time, and it's already gone through processing with me. Now, I added in the processing to make it simpler. Of course, you could do exactly the same on the raw information before any processing happens in there. Okay, so last one before we have a break. This one is about now that we've got the data, what can we do with it? What can we do with the data now we've got it? And this is looking at the new BI tool from Amazon, which is called QuickSight. So QuickSight is fairly new. It's available in two different versions, the standard and the enterprise version. It's designed to be price competitive, or very price competitive with the traditional Tableau and business BI tools. It's very closely integrated with all of the various different data provision systems that AWS has, but you can also link it into outside data sources as well. It's a fast, cloud-powered business analytics service to make it easy to build visualizations, perform ad hoc analyses, and quickly get business insights from your data. It's also important to say about this, I think, that this is one they're really adding on new features all the time. One other thing before we get into it to mention is Spice, which the way that it works is because you have large sets of data, in order to make it quick to work with, when you create a visualization, you can either query the original data or you can put your data into Spice, which is essentially a data lake, which stands for the Superfast Parallel In-Memory Calculation Engine. I imagine there's a group of people in AWS sitting trying to think of something that would make Spice, because if ever there was a stretched naming, that's it. But anyway, the idea is that it's in memory, it's fast, it allows you to do much quicker generation of your visualizations. Of course, if you've taken your data and put it into Spice, it's not going to be the latest data. You have to refresh your Spice, which is always fun. Okay, those are the prices. First gigabyte of Spice is free, 10 gigabytes of free with standard or enterprise, $25, 25 cents per gigabyte standard, $38 per gigabyte enterprise. That's because the enterprise version is encrypted at rest, whereas the standard is not. Okay, so I'm going to take you through a few visualizations here. First of all, I'm going to connect to Athena. So I've just clicked onto, you'll see here in the background, these are all the types of data sources you can use. Salesforce, you can upload a CSV, S3, Athena, RDS, Redshift, MySQL, Postgres, SQL Server, Aurora, MariaDB, pretty much everything that you would, well, not everything, but so I'm going to connect to it, and connecting to it is as easy as typing in, choosing the setup that I used, and choosing the table that I created, sentiments, tweets, which is now effectively connecting me directly to that bucket. I'm going to pop it into Spice. And then I'm going to visualize. Okay, you'll see on the right-hand side here, it's importing to Spice. It does take a little bit of time. I've sped this bit up, as you can see, by this slightly crazy whirler over there. But obviously, depending on the number of records, the length of time. But again, if you don't need real time, then it's well worth doing it in here. 116,384, and then I think it finishes with 164,113 rows have been imported. Okay, now on the left-hand side, the visual types, you can see the sort of charts that you can create. It's actually set on the little flash, which is autograph, which is, again, it's an automatic graph rather than a scribble. It will create the chart that it thinks is best suited to the data types that you've got here. So let's have a look at hashtags. So I can see here, for example, the number of tweets in my data set, which were from Nike, United Airlines, and Pepsi, which is quite interesting. Though not surprising. I can specify and change the fields at any point from the field wells at the top here. So if I want to change from hashtags to see sentiments, for example, this will show me the number of sentiment neutral, sentiment positive, sentiment negative, sentiment confused. It's also worth saying you can change the color and layout of these charts at any point that you want to as well. Okay. Now I want to map hashtags against sentiments. Sentiments against hashtags. So now I can see that under Sentiment positive, Pepsi seems to be doing very well, but again, under sentiment negative, Pepsi has also had a fair amount of bad press during this point in time. Okay. This actually started collecting this data, I think, 2 days after the United Airlines incident, so I wish I'd done it 2 days before, but there you go. There's still quite a lot of bad sentiment towards United. And here we can see, same thing, but just changed differently around. So you can actually group them by the way in which people are reacting to the sentiment of the tweet. And again, this is from the emoticons and the text only. It's not yet including the images. I can also add in now the retweet count, so where I have a particular numerical value, I can see where things are being retweeted, and clearly there's a lot of retweets from Pepsi. You'll notice that this is being summed at the moment, so you've got a number of different ways in which you can aggregate that information, which will give you obviously different displays for those of you who are work with data. But it's very quick and easy, and it's designed to be very user-friendly, very simple to be able to provide and create these charts, especially once you've got the data set up. And again, there's no server. This is a service. There's nothing happening kind of under the hood apart from I've provided these raw text files which are going through Athena, which are then coming to here. Okay, I can then zoom in to focus on particular key points. So I'm only interested in focusing on Pepsi. And so I can then focus in a bit further on those. And further, if I want to, I can focus in on specifically on negative emotions, or I can change the color, which is in there as well. See, on the left-hand side, I've now got an applied filter. We'll come back to that at several points during this part of the demonstration, because you can apply it either to an individual piece of analysis or to all the analyses that are in your system. And you can move it around, shape it, because you can share this in multiple different formats, which we'll see. You can share that information. You can change the chart type once it's in there, and obviously change it back if it's not the right chart type for you. I'm going to add in a separate visualization. And this allows me to drill down a bit further and to see which is the tweet that's being retweeted so much, which is no real surprise for those of you who followed the news for the last few weeks. But you can actually use it, obviously, as we're seeing here, for discovery of information at any given point. Okay. Again, this is using a very simple chart, a very simple visualization here. And you can change it around. Now, if I now go back into the data, so underneath all of this, you have another view, which is the view with the data. And one of the things that you can do with the data is you can also filter the data. So what I want to do is filter out, all of only having English as the language of the tweets that are being included. So I can do that, so my visualization, when I'm building my visualization, I can choose to exclude at the data point rather than at the visualization point the information. And this isn't affecting the underpinning data, but just the data that we're working with in this particular visualization. So you could have 20 people working on the same data, and each of them can cast this data however they want to in here as well. You also have the ability to create new... are we going to do that? Oh, yes, we are. To create... I don't want to give the game away if we're not. Come on, press, yes. To create new fields. So new fields are basically fields that are calculated based on the information that's already there. So in this case, I'm going to do a really simple thing and just create a differently formatted date, but I might want to calculate the value of two different numerical fields. I might want to calculate the date difference between the start and the end date. So if I'm doing a course, for example, I might just want to have a column that tells me the duration of a course, and I can calculate that as well. So all of those things can be done relatively simply within here as well. And then that becomes, in your data set, there you go, tweet day field that I've just created at that particular point in time there as well. Okay. Once you've made a change, you can then, that's automatically saved and visualized. Sometimes it will need to refresh Spice, depending, and in this case it will, depending on the underlying information, so it will then run through and refresh Spice if necessary. Now in this case I've reduced down the data because I want to show another feature here. So I'm going to do another demonstration here showing tweet day by hashtag, showing what days people were tweeting about particular hashtags. Now what you'll see here is there's a little bit of a gap in the data, and that's because my data was flowing through more quickly for Pepsi than it was for Nike, and I'll show you how that gets refreshed in a moment. Okay. So count of records by tweet day and hashtag. Let me move this forward a little bit here because this is... Oh, sorry, one thing. And because it's a time field, I'm grouping this now by year, but that's not very useful. So at any given point, you've also got the ability to filter down and to change the grouping type of a particular element. So if I change this, instead of aggregating by year, I want to aggregate by hour to give me more granular results. If I wanted to see behavior over a period of time, I might want to do it by month, and so on and so on. So here I can see the spikes in information, the spikes in tweets for United occurred at these particular key points. There was 150, this is by the hour, 150 tweets specifically related to United at that particular point. And so I can look at that, compare that, for example, to news stories, compare that to what's happening, and get a deeper level of analysis from there as well. Okay. The little slider at the bottom allows you to zoom in and zoom out of particular data patterns in there. Okay. And of course, again, you can show sentiment over time or whatever. Now we've got this information in here. We're able to work with this information. Now something else, I'm just going to push this forward a little bit because I'm conscious. There are, of course, loads of different data charting types that there are, visualization types that there are in there. The KPI visualization, which has just been added, bottom right-hand corner, always adding new ones. You have heat maps, you have tree maps, line charts, area charts, you have pie charts. You know, you've got a wide variety of them, all of which can be customized to the needs that you have to meet the data outputs that you want to have in there as well. And again, when they're in there, they can be filtered, aggregated, just as we're doing in here. Okay. So again, I'm going to filter this one down. Creating a filter which is only United. And I can also choose if I want to filter it for a particular period of time. Or anything, fairly standard. But again, you know, the thing to emphasize here is that this is $9 a month, and it's a tool that's being built on all the time and provides a very, very cost-effective, I think, alternative, as well as the fact that you have, you know, as I say, we're using one tiny data set. You can link in all of your Amazon data sets or external data sets as well into this. Now, I want to show you one more thing with this, which is where you can get interesting is this is obviously a very simple data set. Now what I want to do is bring in a second data set, which is this one. So this piece of information here is the share price for each of these, each of the companies that are represented by the hashtags, Nike, United, and Pepsi, at every second for the period of time that I'm calculating the information in here as well. So I want to bring that in and be able to follow that through. So again, first thing I do, put it into S3. It's just a CSV file, 200 megabytes. Bring it into Athena, and then create a data source inside of QuickSight so that I can start to play around with that. So just showing you how you can connect two different types of data. Here I've got my price data information. What I want to do is connect it in some way with sentiment tweets. I'm going to just directly query it this time for speed. And you see here, I can actually choose to associate different tables. And for those of you who are used to working with data, you'll see here you've got a join between the two different items. You can choose what type of join it is and perform that join here. Of course, you can perform it in the raw data as well. But that will then create a new data set which can then be taken in and we can start to visualize that. Okay. So if I take that in and visualize that, I can start to begin to create some really interesting visualizations. So I'm going to add a title. Tweets and sentiment against price. Capital P. So I'm going to, as you would expect, bring in the hashtag, bring in the sentiment, like we did earlier on. All good. But now I want to, alongside that, I want to put in the price. And again, it's grouped by year, so I want to make a change on there. So that can show me the price sum. I'm going to change it to the average at this point. But what I've got here is two different analyses, visualizations side by side. I can share these out as what's called a story. So I could very easily just create a story which is something like this, where I'd be able to share it with somebody and they can then see the steps that I've taken through and the steps that I've taken to produce my story. But there are a couple of other ways to share it which are a little bit more interactive as well, which I think are interesting. So if I just go back into the main QuickSight window and back into my analysis. And I want to add in a third visualization, the final visualization. Just to say here, a new thing that's been added recently is the ability to export to CSV. So if you've got a bunch of data and you just want to export the data, you can also do that. I'm going to apply a filter first so that I'm only dealing with the period of time that you see here. I'm actually missing information for, so I only want to deal with the period of time that I'm applying data to, have data for rather, sorry. And when I do this, what I want to make sure is, okay, so that's working for the bottom one, not working for the top one at the moment, but I can change it to apply to all visuals. So it will format the visuals for all, which is much better if you're trying to tell a story. And then finally, I want to add in one more filter. Which is to include just Pepsi. So, you know, I've noticed something that's interesting. I want to zoom in, I want to focus, I want to let the board focus on Pepsi and only Pepsi. So I've zoomed down in all of this so that I'm ready for that to push through. Again, apply that visual. So now I'm only seeing Pepsi data in there. Okay. So once I've got my third visual in there, I want to be able to share this out. So this is just the retweets. And then, again, same thing. Going to retweet it by the hour so I can overlay all those pieces of information together. It's just applied to Pepsi, just between those dates that I selected. And I can see that information coming out there. Let's extend it out so I can see the pattern of when that tweet was retweeted. And then finally, a little bit of jiggery pokery. Sort of thing when I do this makes my design team cry. Okay, so finally, with all of this set up, I then got the information out. I think it's really interesting. I want to be able to share it, so I'm going to share it as a dashboard. And a dashboard is something that can be shared with other people, and I can create accounts. If I got the standard version, I can just create accounts based on an email address. If I have the enterprise version, I can integrate with an Active Directory and share it within an organization. And basically, this is a dashboard. A dashboard is effectively, well, you'll see it in a second. A dashboard is effectively allows somebody to look at the charts I've created, and doesn't allow them to create new charts, but allows them to filter on the existing charts and to manipulate the data in that way, which is quite interesting in terms of what they can do. So they can turn on and off the filters as well in there. So we're going to pause now for a short break for 15 minutes. Just to summarize where I think we are, we've looked at some of the elements of being able to capture information using Kinesis to bring through large amounts of streaming data, being able to put that information into various different places, for example, a bucket, a database, or wherever. Being able to pull that information out. Of course, you could put it in a database and analyze it there, but also being able to do it in real time and streaming through Athena. Taking that Athena content and being able to take it into QuickSight, analyze it, play around with it, and keeping it, fresh and up to date, and being able to draw conclusions from it. Also worth mentioning again, just reminding you of Lambda, which is that little thing that sits there, which takes just a tiny little bit of code, runs and does whatever you want it to do. In our case, analyzing the tweets for positive, negative sentiment, but we're only paying specifically for the time that we use it for, and we don't have to manage the infrastructure there. That's all done for us. And right back at the beginning, when I did the cloud formation, running that bit of code, that creates anything that I need to have created in the background. So it's a very, very simple, repeatable process. So thank you all for listening so far. If I could ask you to take 15 minutes, there's tea, I think, there's something out there, and then it will come back for machine learning and AI. So thank you very much.
Oh, you okay?
Yes, I think so.
Great.
I'm very hot.
I understood almost everything.
Well, hey, there you go. You can have a job now.
Yeah, no.
That's the technical job.
Thank you. That's incredibly timely. We're just sort of weighing up analytics tools, BI tools.
Excellent.
And I've got a Tableau background. One quick question: is there any kind of geographical visuals that you can do in QuickSight?
At the moment, there isn't,
Right.
but it's the most requested. So you can request features. So it's the most requested one. So
Right.
although I couldn't officially say, I'd be amazed if there wasn't within 3 or 4 months. To be
That's
perfectly honest,
really good to know.
certainly